The Blockchain Show is a podcast that demystifies cryptocurrencies and distributed ledger technology.
Hello, everybody. Welcome back. This is The Blockchain Show, episode number 151. I've got a guest here from SKALE Labs, the CEO, Jack O'Halloran. Jack, welcome to the show.
Hello. It's a pleasure to be here. Thanks for having me on, and excited to get into some content today and discussion.
Yeah, well, the pleasure's all mine. I'm looking forward to this talk. Just since it's the first time on the show, would you mind just kind of further introducing yourself?
Yeah, my pleasure. So I've been doing tech startups in Silicon Valley for 15 years now. Just kind of dawned on me the other day that it's 15 years, and I realize I'm getting kind of old, but that's another topic. And have been always involved in deep tech and kind of frontier tech areas. So I was at Good Technology. I was an exec there, and we sold to Motorola for $500 million. Roughly, it was a cryptographic secure messaging platform used by majority of the enterprise. Then I started doing my own startup. So founded a company called Incentiline. It was a digital currency platform, and you could actually mint currencies inside of enterprises and use them for resource allocation. So I can pay for things internally. For example, NASA could pay for a wind tunnel or supercompute time. And reality was that was 2008. It was a little early. We were a little ahead, and ended up pivoting into building the world's leading AI machine learning platform on the commercial side for life science and biotech. So did that for many years, and all the while, I think it was 2011, started reading the Bitcoin white paper. 2013, started acquiring Bitcoins and kind of getting in the game. And really, it was fun. I got to enter the space as an enthusiast. And then, being a tech entrepreneur, as I was getting my next business started, I was working again on SaaS, machine learning, and just kept spending all my time reading about crypto, which I think a lot of people listening today may know exactly what I'm talking about. I went down the rabbit hole and then met Stan Kladko in 2017. And we were introduced by a couple investors, Rick Thompson, Mike Maples, Sonny Dillon, and we started working on SKALE. So that's a quick background.
That's very impressive. I think that, just that whole lifestyle is so interesting to me, just tech startups and just working in Silicon Valley. We're going to be talking about, obviously, scalability today. I mean, the name of the company is SKALE Labs. So I was hoping you could break down a little bit the different ways to verify a blockchain, because it's been, I don't know, maybe 50 episodes or so since we've even talked about any of these. Could you tell us how the industry is working and what you guys are trying to do?
Ethan, great question. This is a fun topic to address, and I'm going to try to approach this from a little different angle than most people are used to. And I think it might shed perspective on really the challenge and nature of blockchains and the challenge around scaling and getting more throughput. So regardless if you're using proof of stake or proof of work, what is involved here is how many nodes, or in non-compute language, these are basically computers, right? That are all running the same version of a software. The quantity of those nodes adds to the security, because there's just more and more independent operators or operators of the nodes that are validating that they have the same thing. And so we could just use a simple example. It's just a ledger, and what we see in the ledger is a balance, right? And all the transactions. And if there's 5 people, and we need 2/3 of them to be bad, well, then those 3 people could collude fairly easily. If there's 500,000 and everybody has something on the line, whether it be compute power they're putting in to win the award or a stake in proof of stake environment, if we have 500,000, it's really difficult to get the majority of them to act maliciously and lie. And so the nature of blockchains is really, the greater the quantity, the greater the security for the most part. And added to that, though, is also the greater the quantity, the greater the time and compute and networking that needs to happen for all of these nodes to agree. Okay, so if we have 500,000, that's going to take a long time. If there's 10,000, that's going to take a long time. Especially, we've seen that in Ethereum and Bitcoin, right? But we also have seen that they're incredibly secure. And so having large proof of work blockchains that are really good at what they're supposed to be good at, and that's security and maintaining the fact that the ledger is accurate. They really are strong where they're meant to be strong. Where they're not strong is speed and agility. And so what people are doing is they're trying to create systems that rely on less number of nodes doing the work. And so you see that in the sharding proposals around ETH2. You see it in the Ethereum killer category, which people are, I don't know if they still are calling them. Maybe they're giving up on that term, but where they're trying to shard and have a large network of nodes, and then any subset is working on a different shard at any given time, which each shard is its own blockchain, and they kind of speak back to a parent blockchain. And so you see the many models where people are trying to really pool security against the bigger group. And so if you look at SKALE Labs, and SKALE Labs is the corporation, we started the research and effort around the SKALE network, and then transferred that over to a foundation, which is it's an open, decentralized network that's run in a similar fashion to how you'd see Ethereum or Bitcoin being run, where the community runs it and governs it. And we got it started, but we still support this network. The SKALE network, what it does is it can have, let's say, 10,000 nodes in the network. And if all of them have to come to an agreement on the ledger, it's going to take a long time and be very expensive. Even though we're running SKALE consensus, which is very fast, the block time's less than a second, and there's other advantages, but it's still going to be costly to store that data across the entire network. So SKALE has a way to randomly pick sets of nodes and align them together to each run unique blockchains. And so 1,000 nodes in the SKALE network could run 8,000 independent blockchains. Each one of those blockchains can run a blockchain and run smart contracts, run transactions, but they can also do file storage, and you can run machine learning algorithms on them, and you can configure them also for privacy. So you can make the transactions private. And so there are a lot of feature advantages that live in this blockchain. And then the beauty of it is it can connect seamlessly to Ethereum. And so you have this large proof of work blockchain. And SKALE is actually, if I got deeper, is actually built into Ethereum as well. But these two things work together, and you've got one chain that's big and public and slow, but really, really secure. And then on the side, you have really a microservices architecture that we would see in a modern compute environment that's supporting the developer with their own blockchain that works seamlessly with Ethereum. So that's kind of a big picture on the premise. And I can get more into proof of work and proof of stake if you'd like. But again, at the end of the day, we're all trying to just minimize the number of nodes that are participating and carrying data and not lose security.
It's kind of blowing my mind a little bit. That's really impressive. You referred to Ethereum 2.0, and I saw a quote from you saying that Ethereum 2.0 is trying to solve the elasticity as well as supply and demand issues of ETH. I was wondering if you could just break that quote down a little bit more for us. Maybe describe how Ethereum 2.0 is different and how this issue is going to be resolved.
There's a few pieces here. So when we think about proof of stake networks require the node operator to put a stake into the system, and they lose that stake if they don't perform well, or if they're Byzantine, or essentially if they're malicious and they try to steal and they collude. And so that's this incentive to act well. There's also something that's been built in around that model called gas. And so what gas does on Ethereum, it's really the transaction fee. And it actually is a security measure. It prevents people doing a denial of service attack on the network, because you basically have to pay each time you ping the network. And if I ping the network a million times, then that's just not worth the cost of attack of just, because DOSing, denial of service doesn't steal, it just kind of pauses the system, and you can kind of hold the system ransom. And it becomes really an ineffective strategy when you integrate gas. But the issue with gas is that it's expensive. And the way that it's priced now, it's fairly linear. There is a component of how busy the network is, but it's not super elastic. And ETH2, we look at ETH2, it's the proposal now, I think, is 32 shards. And by the time you all are listening to this, it may have changed again. It keeps changing, keeps halving. And the more shards, there's just more challenges of network operations. And and they're running. And so what so each one of these shards is able to, you could use any one of them as if they were an independent Ethereum in the ETH2 proposal. And so what's happening is you get a lot more efficiency and speed gains and throughput because you've divided Ethereum into 32 pieces instead of one. And so maybe at the minimum, hopefully it'd be 32 times faster. It doesn't work out necessarily that way, but it ends up being roughly in that category, faster and having more throughput. Okay. And so the elasticity piece is there's also an economics improvement. So instead of just having the gas be fairly standard for paying per transaction, those fees to use the network are dependent on network loads. And so if the network's really highly utilized and most of these shards and blocks are being filled up, then it just costs a lot more. And if it's not, and it's like really, really inexpensive to the point where it's almost free. And there's also even, it's not just a graduated curve, there's a Nieva curve that what happens makes it a lot more expensive at a certain point to use the network, which increases fees, which incentivizes more people to run nodes, which decreases the fees because there's more supply. So it's a supply-demand balance and dance, and the Scale network operates in a similar way. And so really it's an innovation around an elastic business model or network economic structure that's integrated with this proof of stake innovation with sharding. So that's it. And sorry if that's a mouthful, but that's the high level structurally of what I meant and around the ETH2O elasticity.
Oh, okay. That makes sense. Thank you for explaining that, because talking about staking rewards comparing to proof of work mining rewards, is that kind of along the lines of what you just explained, or is there some difference there?
Yeah. So if you think about it, when it comes to proof of work, everyone's putting on the line compute power and money. And it is a way to basically, it's a game theory that says, we know you're not going to be bad because you're kind of like participating by putting hashing power down. It incentivizes people in a broader way to be alongside of the majority. That's why proof of work networks are susceptible to 51% attacks. Proof of stake networks that are Byzantine fault tolerant, the ledger can't change and money can't change unless there's a 67% attack in most of them. So, but they can be paused if there's over 33% that are bad. So anyways, because in a proof of stake environment where you're not putting down hashing power, you're putting down basically, money as collateral, it changes the dynamics of the security. And so proof of work, again, is energy intensive because we're putting all these machines up next to each other that are really like, fighting for the right to win the block, and also ensuring that they're being accurate because there's incentives for them to be accurate. And then the incentives are not by block in a proof of stake network. They're really structurally, they are by block, but it's more about I put something down and over time, if I'm bad, I'm going to lose that. Like in Scale, I have to put maybe roughly $100,000 USD peg equivalent into the network. And, if I act bad and try to steal money, then I can lose that money.
It's crazy how human nature just kind of pervades all aspects of life, and there's bad actors and just about everything. And I can tell that there's so much thought that goes into preventing these, bad guys, for lack of a better term.
By the way, just to reply back to that really quick, because this is the piece that's really interesting about the space is you can have the world's best mathematician, the world's best economist, the world's best technology developer, and their skills alone are pretty useless. And their skills combined are incredibly valuable when it comes to blockchains, because it's really, there's no way that anyone can prevent an attack if 100% of the nodes are saying the same thing. So it is reliant on people and incentives. And it's a very cool confluence of factors that equate to security and performance at the end of the day. And it's pretty like intellectually fun stuff.
Absolutely. I was browsing some pictures, I think, on Reddit, Old School Cool, and there was this 100-year-old vault door from somewhere in Alabama. It was just insane, the amount of craftsmanship. It must have taken them, hundreds of hours to create this huge vault door just to keep people out. And I think about nowadays, all the time that's spent just to make sure that, you know, digital assets can be sent effectively. It's not quite as visually pleasing, but you know, it's definitely there. Just to kind of go further, talking about longevity, how does a staking system compare to, say, like a proof of work system?
Yeah, so I actually am a big fan of proof of work and proof of stake. And so Scale is designed to plug in to Ethereum. So within the Ethereum mainnet, and really one way we've been describing Scale is it's Ethereum as a service that can bring to your fingertips the best of Ethereum at any time. And you get your own kind of version of Ethereum that's really fast. But as research improves, it's future proof, because let's say roll-ups are really critical and important now. And Scale has a BLS roll-up that's popular, that we've integrated as an option to use, or that we're integrating. But hey, if optimistic rollups are really the thing, well, there's going to be a configuration option. And so Scale is bringing to each end user, or each developer and end user, the best of Ethereum. And you know, I hope that proof of work systems survive, because you know, they are not energy friendly. They are kind of V1, but they're really, really secure. And so for certain, I kind of equate it back to your analysis, is this big, heavy, beautiful vault door. Guess what? Every time you want something out of there, you got to drive to the bank. You got to, you know, do identification checks. You have to certify, and then someone has to literally go down there and move the door open. And it's really secure, and you should probably just put stuff that you don't need access to very often. But in the other parts of our life, hey, we're comfortable using credit cards and debit cards and carrying cash in our wallet. And if we lost that, well, hey, it's not the end of the world. But they're at our fingertips, on our hip, and we can use them. And they're generally less quantities and backed up in certain ways, but readily accessible and agile. And so that's what I think Scale's trying to build, is, you know, that wallet that every user has. And it's not a wallet because we partner with wallet companies, but in essence, it's those things you want to use every single day to use business applications, games, centralized finance systems, et cetera. And those use cases require more functionality than an old vault door.
Yeah, that's very, very interesting, man. I like that. Now, speaking about profitability, because it's a very important part of what makes proof of work. You know, it's profitable, can be profitable. But what are some key points that highlight the fact that proof of stake is profitable?
Yeah, that's a great question. So if you think about proof of stake, the cost of running the system is dramatically lower. You just plug a server into a wall, right? And the reality is you have to run it probably in a co-location center, or you run bare metal in a good environment, or you use the cloud. And you're probably spending anywhere from like $100 to $600 a month, depending on your setup and your economies of scale. So those costs are dramatically lower than running the energy game. Now, the way that the ROI model works is, I like to think of it as an Uber. But instead of putting people in cars, we're getting servers to do work for people. And so you can have your car, i.e. your node, your server, and you lend it to the system. And the system then is allocating it and using it and applying compute and file storage and helping people run smart contracts. And at the end of every month, you know, you get paid. And so there's some basic, simple economics to say the money people pay for the service needs to be worth more than the basic costs, the operating costs to run the system, and have a baked in margin for the operators. Now, what is different about this system is that there's no middleman. It's not like Scale Labs is there taking a rake or a fee off of every transaction. What's happening is that all of these fees are going to the drivers, i.e. the node operators, who also then pass money back to people who delegate, who fund their operation. So if you bought a Scale token, you could stake it in the network. It increases the security and supply of the network, but you constantly are getting a dividend. And it's almost a modern decentralized finance where you're staking into the network and you're getting a return in return for the work that you did for the system. So these things have to be profitable when you're designing economics for these systems. If you don't take into consideration the drivers, that they need to make money and they have costs, then you're going to have a system that dies, because the incentives to keep working for the network and the system will not be long if everyone's playing this like, let me bet on a token game and bet on a short-term upside.
Right. There was a lot of that going on as well. And I think some of the hype has fizzled out and we're starting to see a lot more functionality emerge, which is really exciting for me because, as we've talked about before on the show, the promise of blockchain technology is not just money, sending money over the internet. There's so many possibilities that we haven't even thought about yet. Yeah. So I really enjoy listening to you break this down for us in a way that is easy to understand. And hopefully there's some people listening that can kind of get excited about what's going on or where we're moving forward.
And hey, just to reply, I think you brought up a really good point. There were some bad things that were happening, and that's natural for a growth stage. You look at what happened in '99 with all these IPOs and all this stuff. It was very similar. Like we've seen this story before, but then there was a delayering, and a lot of the people making bad investments were moving. No longer had capital to do so. The companies that raised bad money and didn't know how to use it effectively ran out of money and went public and couldn't support operations. So we had this cleansing that resulted in filtering that resulted in a lot of really good stuff. And so the same thing's happening. But what I will tell you that not enough people are talking about is how many people in these systems where investors got huge discounts and then they had no lockup. And then you have teams that bought token or that had tokens for the work and didn't have lockups. What happened is a lot of people in the retail market, some people would call it, buy tokens, and then what they're doing is they're just buying the upside because these people have immediate and initial liquidity, and they basically got dumped on, and then the market changed, and all of a sudden the people buying second really are left holding the bag. And one thing we're doing with our launch is our team has a 12 it'll be 36 months following network launch of a vest period, but a 12-month lockup immediately following the launch date. And that means we'll have a vest of over 5 years, which is long, but we have zero liquidity for an entire year, meaning if it's worth $1 billion on day one and we don't make any, and it matters what it's worth in the long run. So our incentives are aligned. And the same thing with our investors. Our investors are locked up from 9 to 36 months in their vesting periods that all start with the network launch. So those are really critical things for network health, but also supporting the people that are getting involved. And you have to protect the people that get involved second. Otherwise, you're not going to have anything sustainable. So we've done that. I hope more people start doing that. And it makes it impossible to have a short-term win for investors and team. But that's what's required to make these things launch well.
Yeah, that's very good to hear. Very sound integrity there. And I did notice that you guys have had some success, raising some funds. I saw Consensus Labs, Blockchange, a bunch of others are getting behind you, and I can see why, because this is very promising. Just wanted to ask you a little bit more about SKALE Labs, where you guys are at in terms of a potential launch date, or just anything you'd like to talk about that you guys are working on.
Yeah, so we are really close. We're in striking distance. We're in code freeze. We've got 128 chains in the testnet going. That code is going to move over to an incentivized DevNet or testnet, where you can see we've got a lot of the world's top validators running the SKALE network in a test environment. So technically, we're really, really close. We're doing an audit with Consensus and QuantStamp, and surely have some things we have to fix, and we'll fix those, and that's just part of it. And then we'll be ready to launch a mainnet. And then we'll also do a public sale. We want to do a compliant public sale that protects people and protects the network. And so we're going to make this so you actually have to use the token. You can buy it. You don't have to be an accredited investor. Anybody can buy it, but you have to stake in the network for 3 months. And you do that during a transferless state. So it's not like the token's being traded simultaneously on exchanges, but we'll have an announcement coming very soon. And perhaps even by the time anyone out there listens, that will be announced. So please keep your eyes open. But these things now start in a way where, it started with Stan and I and a vision, and then, then a core team of 30 people at SKALE Labs. And then there was a transfer of ownership of all the IP and the code and the assets and money over to the foundation. And now the community runs it. So it's just, and this launch is the next step in making this more community run. And hopefully it serves the needs of developers. And and the goals we have with decentralized networks and blockchains and DLT, et cetera.
Very cool. I'm just curious who this is geared towards, everyday users or larger institutions. Like, who do you see utilizing Scale Labs kind of right away?
We're following the model of Amazon Web Services. So AWS really did a great job when they launched of getting all the startups to use their product. One of our investors has this quote he always says is, sell Bibles to the Christians, meaning it's much harder to change people's religion as a business model. So you may as well sell the product to people that they want. There's a whole huge burgeoning market of developers in the startups, of anywhere from 2 to 50 people across gaming, DeFi, B2B disruptors across the entire app stack. If you look at the whole app stack in mobile, every single area, we see amazing projects being started where there are middlemen there taking rakes that are far bigger than they should. And they're going in with disruptive business models. What they've been lacking, frankly, is something that produces less friction. So even though I can come to you as an end user and say, hey, guess what? If you use this music streaming application, you get to participate in the ad revenue and the artist gets more money and you get access to better content. And we're basically circumventing the labels. All of these things are cheaper, better, faster, and more rights are distributed fairly. And you're like, great, but if I need a PhD and it takes me like 10 hours every time to use the product, I'm never going to use it. But if it's plug and play and it feels like I'm using a normal music application, then guess what? I'm going to use it. And so look at someone like Audius, what they're building. They're really a great example, I think, of a very easy to use, frictionless Web3 product. And there's a lot of projects behind them that are also producing similar results.
Yeah, it's exciting to see some of those start to emerge. I think it's going to really help more people adopt. Sometimes I wonder, do people just not care, or are they not aware? Why do people stick with all these other large corporations that mine their data and exploit them? And I think a lot of it is just, like you said, it's just not easy enough yet, or like you need a PhD. So that's a really good point.
Yeah, and my new kind of the way I'm framing this, and just I'm doing this as an end user, because the customer, the network's customer is the end user. We support developers, but we need to make sure that their users are happy, and so we use a lot of products so we can have empathy. And I think it's very simply like we need to make it easier for people to get money in and have that money accessible, because our credit cards aren't connected, right? So we need to make sure our crypto can get connected. And obviously we need to be able to transfer fiat into crypto. But when we have crypto, if every time we have to go fetch our ledger to use this stuff, then it's harder. Then we need to be able to authenticate into different applications easily. And then we need to be able to use them in a way where we have like seamless, high speed, low cost experience. And so there's a lot of startups working on each component of that. And once all those things come together, which I think by the end of this year, we're going to have a lot of very good options for each one of those categories, we're going to see the uptick.
Awesome. Well, that is very good to hear. And I've really enjoyed talking with you. So I appreciate your time with us. I wanted to just give you a last opportunity to, just in closing, let us know what you're excited about and where people can go to potentially learn more and interact with you.
Yeah, so I'm excited about this industry as a whole. And I'm really excited about, obviously, the launch of the SKALE network. And there's 35 dApps that are launching that are in the SKALE Innovator program. So I'm excited to see their success and support them after the launch. But if you'd like to learn more, you can go to skale.network. That's SKALE with a K. And you could also follow me on Twitter at Jack O'Halloran. Those two would be really good ways to get involved. There's also the Telegram, and I think it's SKALE Official, SKALE with a K, at SKALE Official. So please join the community. It's an open source project, just like Ethereum and Bitcoin. So we're looking for people to contribute, play a role, run a node, run a dApp, and get involved any way you'd like. Yeah, so thanks, Ethan. This has been really awesome. I appreciate your questioning, and I'm a big fan of the show.
Oh, well, thanks, Jack. The pleasure's all mine. So I wish you all the best, and hopefully we can connect again, either sometime this year or anytime you want to come back, you're welcome.
Hey, I'd love that.
My guest today was Jack O'Halloran, the CEO of SKALE Labs, the Ethereum scalability startup on its way to mainnet launch and fresh off of a $17 million funding round. Thank you so much to you for downloading, being a part of this podcast. Keep your emails coming in, info@theblockchainshow.com. You can join us on Facebook. Check out our Twitter @blockchain_show. Connect with us at minds.com. You can find me there at KinderConnect or the Blockchain Show page. As usual, if you know anybody in the space who would make for a good guest, whether they're an expert of cryptocurrency or a CEO of a blockchain startup, anyone that's just interested in the space. And, sometimes we have just everyday people like me. Shout out to Nelson White Tan way back in the day. This has been a lot of fun doing this podcast. My favorite part is interacting with the audience, with you, and with some of our guests that just really say some profound things, like not just about blockchain technology, distributed ledger technology, or cryptocurrencies, but just about humanity. It's amazing how reflected we can be in technology. And so it's really cool. Thanks again for joining me, and we'll see you next week.